So welcome to all of you. Now we will revise the chapter 4 of the numerical methods and its application. That chapter 4 is numerical solution of first order ordinary differential equation. Okay. So you know that there are four methods. So first one is the Taylor series method. That means what? We have to solve the differential equation like this: f of xy, f of initial condition is provided to you, y of x naught is equal to y naught. Okay. So what is the Taylor series for this one? So this is y is equal to y naught plus y naught plus. So y naught is just we write this y naught as y of x naught. Okay. So y of x naught. Just you can write y naught also. So plus x minus x naught into dy by dx at x is equal to x naught plus 1 upon 2 factorial x minus x naught bracket square d2y by dx square at x is equal to x naught plus 1 upon 3 factorial x minus x naught cube d3y by dx cube at x is equal to x naught plus dot 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 plus dot dot dot. Okay. So now this is for y is equal to x naught. So for this is the solution. So what we have to do here? You have to find the dy by dx at. So dy by dx is already you have. You have to find at x naught y naught. So that is what we have to find this at x naught y naught. Okay. So d2y by dx square at x naught y naught. Okay. So you have to find the second derivative, third derivative, and so on. And just you have to put here. Just you have to put here. You get a series. You get a series. We get a power series in terms of x minus x naught in powers of x minus x naught. So that means if y is equal to x naught is there, we get a power Taylor series in powers of x minus x naught in powers of x naught now here, because what these are the constant. You can find the values of this one. Only you have to find the values of this one, dy by dx, d2y by dx by 30. So this. Okay. So now suppose we have this equation. So f of xy y of 0 is equal to y naught. What is here? Y of 0. Then your Taylor series will be what? Y of x naught. That means this is y of 0 plus now x dy by dx at x is equal to x naught. That means x is equal to 0. This is your what? X is equal to 0 plus 1 upon 2 factorial x square d2y by dx square at x is equal to 0 plus 1 upon 3 factorial x cube d3y by dx cube at x is equal to 0 plus dot dot dot. Okay. So that means what? If y of 0, if your initial condition is y of 0, then this is what Taylor series. The Taylor series expansion is in powers of x in your solution. Solution will be what? In powers of x. This is in powers of x minus x naught. So that we have to remember this. Okay. So that means what here also one thing is you should know that. So what is the coefficient of x for this one? Coefficient of x is what? Coefficient of x from here now. We see what is this? This is dy by dx at x is equal to 0 now. At x is equal to 0. Okay. So now coefficient of x square is the what? d2y by dx square at x is equal to 1 upon 2 factorial. 1 upon 2 factorial d2y by dx square. Coefficient of x7 suppose. Coefficient of x9 suppose x9. So this is what? 1 upon 9 factorial d9y, the ninth derivative at x is equal to 0. Okay. So that means what? To find the coefficient of x to the power 9, we need the ninth derivative. We need the ninth derivative. And ninth derivative means what? This is f of xy. This is the first derivative of f of xy. So for this coefficient of xy, you need to differentiate f of xy one times only. You need the second derivative, but you need the first derivative of f of xy. Right? To find the coefficient of x cube, you need to differentiate this 2 times only. This is the derivative. If you differentiate 2 times, that means this is the third derivative. This is the third derivative. That means if you want the coefficient of x to the power 9, so for f of xy, so we want the 9 derivative. That is no problem for this one. But here what? We have to differentiate this 8 times. We have to differentiate this f of xy with 8 times. Note that this. Okay. So this is the these two are very important here. Then what? We have to find the coefficient of x square, coefficient of this also, coefficient of x to the power suppose x to the power x naught cube. If you want the coefficient of x minus x naught cube, then what is this? This is 1 upon 3 factorial d3y by dx cube and x is equal to x naught. This is the coefficient of x minus x cube. So you have to find the third derivative. That means you have to differentiate this 2 times and you have to find the values at x naught, y naught. Put x is equal to x naught and put y is equal to y naught now here. So this. Okay. So value of y is this now. Okay. So we will solve some problems so that you will understand how to face the problems or problems by using the Taylor series. So note that the method will be explained. So that the solution of that problem, which method you have to apply, that will be the question. Okay. So we'll do some problems. Suppose we have the differential equation dy by dx is equal to x minus y square and this y of 0 is equal to 1. Okay. So we'll find first 2 terms or first 3 terms. Okay. So first 3 terms. First we will solve this one and then we will see which problem will be asked like this. Okay. So what is your Taylor series then? Y of x is equal to y naught plus x into dy by dx. So now 0 is there. 0 is there. That means in powers of x we get dy by dx at x is equal to 0 plus x square upon 2 factorial d2y by dx square x is equal to 0 plus 1 upon 3 factorial x cube d3y by dx cube x is equal to 0. Okay. So we'll do only these 3 terms. We'll find only the first 4 terms now here. If there is first 3 terms, then do only this. Don't find the third derivative now. If there are 3 terms, go to the second derivative. Okay. So now here, okay. So we'll find dy by dx. dy by dx. dy by dx is what? X minus y square. So dy by dx at x is equal to 0. X is equal to 0 means y is equal to 1. X is equal to 0 means y is equal to 1. Y is equal to 1. You have to find this dy by dx at x equal to 0 means x is equal to 0, y is equal to 1. You have to put here. So 0 minus, so this is minus 1. This is minus 1. Then d2y by dx square. d2y by dx square is what? 1 minus twice y prime. So this is y prime actually. No? Y prime. Value of y prime is 1 now. Okay. So d2y by dx square at x is equal to 0, y is equal to 1. Get right. So you have to put x is equal to 0 and y is equal to 1 and y prime is equal to minus 1. So y prime is equal to minus 1. So that means what? This is 1 minus 2 into y. Y is 1. Y prime is minus 1. So this is 3. We'll find one more this. Okay. So this is what? d3y by dx cube. So this is what? Minus twice y double prime. Plus, not plus, then minus. Okay. Minus twice y prime square now. Minus. Because what? We have to apply the product rule here. Twice y as it is, derivative of y prime. So that is y double prime. Then minus 2 y prime as it is, derivative of y prime. Y prime into y prime square. Okay. So d3y by dx cube at x is equal to 0, y is equal to 1. So what is this then? Minus 2. Y is 1. Y double prime just you have calculated. This is 3. Minus 2. Y prime just you have calculated. This is minus 1. Bracket square. So you have to do this fastly. So okay. So now this is what? Minus 1 square. So this is minus 2 will be added. So this is 4 now. This is 4. So we put here. So what is your y then? Y is equal to. What is your y naught? Is 1. Plus x into derivative. Plus x into minus 1. Plus x square upon 2 factorial. X square upon 2 factorial. Second derivative is 3 now. 3. Plus x cube upon 3 factorial. So derivative is 4 now. Okay. And so on. So y is equal to 1 minus x plus 3 by 2 x square plus 4 by 6. 4 by 6 means 2 by 3. This is 2 by 3 x cube. Up to 4 terms. Okay. So what will be? They will ask find the coefficient of x square. Find the coefficient of x cube. Okay. So if or they will find the value of y of 1 suppose. So what is y of 1? Put x is equal to 1 here. So it will be what then? First 3 terms. If first 3 terms, only I have to consider this now. If first 3 terms, then don't find the third derivative. Don't find the third derivative. Only do this one. Then problem will be easy now. Okay. So if they ask only the find the coefficient of x square. So find the coefficient of x square. So if you want the coefficient of x square, this is what? d2y by dx square at x is equal to 0. 1 upon 2 factorial. Okay. 1 upon 2 factorial. What is this dy by dx? Is what? X minus y square. The differential this is 1 minus 2y y prime. So we have the value of y prime now. Y prime. How to find value of y prime? Put x is equal to 0, y is equal to 1. So y prime is minus 1 now. Put here now this is what? 1 minus 2, y will be 1, y prime will be minus 1. So this is 3. So this is what? 1 upon 2 into 3. So this is 3 by 2. So 3 by 2 means 1.5. Okay. So if they ask like this. Okay. Up to first 3 terms will be there now. So I have solved this one more extra term here. So but you have to do up to the for this competitive exam or this online internal exam. So it will be up to the first 3 terms. Okay. So we'll go up to the first 3 terms. Okay. So next here, so we'll solve up to the first 3 terms only. Okay. So we'll not find the third derivative now here. Okay. So we'll take next problem. We'll take next problem. Okay. Suppose we have this dy by dx is equal to x square plus y of 3 is equal to 4, y of 3 is equal to 4. Okay. Find coefficient of, so now this is power of, the series will be in powers of x minus 3. So we'll find the coefficient of x minus 3 square only. We'll take a problem for x minus 3 square. Okay. So we'll solve the problem detail. But if you want to solve only this, that we'll do later on. First we'll solve this whole problem. Okay. So this is y is equal to y naught plus x minus 3 dy by dx at x is equal to 3 now. Because initial value is x naught is 3 now. Plus x minus 3 square upon 2 factorial dy by dx at x is equal to 3 only. Okay. So we'll do only for first 3 terms. This will be the first 3 terms. Okay. So now, okay. So your dy by dx. Dy by dx is what? X square plus y. Okay. So dy by dx at x is equal to 3 means y is equal to 4. We have to put x is equal to 3, y is equal to 4 now. So 9 minus 4. 9 minus 1, 4 is 5 now. So this is your y prime now. This is your y prime. At x is equal to 3. Okay. This is the value. Okay. So d2y by dx square is what then? Twice x minus y prime. Okay. dy by dx means y prime. Okay. So now this is y double prime. Y double prime. We'll write that y double prime. So y double prime will be what then? Y double prime will be what? You have to put x is equal to 3, y is equal to 4. Will be what then? This is x is equal to 3. So 6 minus y prime. Y prime is what? 5. So this will be 1. This will be 1. So what is your then y is equal to y naught is what? 4 plus x minus 3 dy by this is 5. Okay. So 5 x minus 3. This sign is a plus, so we will write the plus here. So this is 1/2 then 1/2 x minus 3 square. 1/2 x minus 3. Here we get all those things. If they want the value of y of 1, find the value of y of 1 suppose. Find the value of y of 1. So you can put here 1 now here, or they will find value of y of 4 then. What is y of 4 then value? Y of 4 will be what? 4 plus 5. Then this is what? 4 minus 1. So this is half. So this is what? 9 by 2 plus 9 by 2. This is not 9 by 2. This is 9 plus this is what? 9. So 9 plus 1/2. So 18. So this is 19 by 2. 9 by 2. So this is what? 9.5. This is 9.5. Easily you can find the value of this one. Easily within a 1 minute actually you can do this one. Within 1 minute. If you have practice, then you can do this in within 1 or 2 minutes now. Okay. So now here what we get now, if you do this one, for this you get the value of, you can find the value of y at any point. You can find the coefficient of x minus 3, coefficient of x minus 3 square, and so on. Okay. So it is very easy now. Easily you can find this one. Even though you can differentiate the third derivative also, if they want the third derivative is also very easy. 2 minus y double prime now. 2 minus y double prime. But we need this value of this one. To find the third derivative, you need the y prime, y double prime. Okay. So that value you need this one. So value of y double prime is what? 1. So this is 1 now. Third derivative is 1. So easily you can find the coefficient of x minus 3 cube is what? 1 upon 3 factorial into the third derivative is 1. So this is 1 by 6. So 1 by 6 is the coefficient of x minus 3 cube. Okay. In this way, they will ask the problem. Here what? Only the function. Function plays very important role here. Okay. So here. Okay. Whatever the function is given, we need to differentiate that. Okay. Okay, so we solve one more problem. Suppose dy by dx, y sin x, and y of 0 is equal to 1, and find coefficient of x square. We'll find coefficient of x square. Okay, so coefficient of x square is equal to what? So we have the formula. So this is what? d2y by dx square at x is equal to 0 now. So I have to find the second derivative now. So this is y prime is equal to y sin x. Y prime is equal to y sin x. So y prime at x is equal to 0, y is equal to 1 is 0 now. Because sin 0 is 0 now here. Okay. So y double prime now. So this is y cos x plus y prime sin x. So y double prime at x is equal to 0, y is equal to 1 will be. Y is equal to 1. So x is equal to 0, so this is 1. So y of 0 is 1, so y is 1. 1 into 1 is 1. Y prime is 0, sin 0 is also 0 now here. Okay, so that means this is 1. This is 1. So coefficient of x square, the coefficient of x is what? 1 half. 1 half only. So the coefficient of x square is half now. Okay, so this will be your correct answer. And if they want, you can write the value of this one. So here we have to find the value of y of 1 is very complicated, because you cannot find the value of sin 1 and cos 1. So the value of sin 1 and cos 1 should be provided. Okay. So now we will take one more problem. Suppose we have dy by dx minus twice y is equal to 3 e raised to x. Y of 0 is equal to 1. And suppose they want coefficient of x cube now. If they want the coefficient of x cube, then what to do now? Okay, now solution. Now this differential equation not in the standard form. You have to express this equation dy by dx is equal to f of xy. You have to express this in the standard form. Okay, so we'll express this equation in the standard form. So that is what? Dy by dx. You have to just shift this to 2y there. So this is what? Minus 2y. Okay, now this is your f of xy divided in the standard form. Now 0 is there. 0 is there. And you want the coefficient of x cube. Okay, so coefficient of x cube is what? 1 upon 3 factorial. So third derivative you want. Third derivative at x is equal to 0 you want. X is equal to 0 means y is equal to 1. Okay, so that you want. So we'll find the first derivative. Now this is y prime at x is equal to 0, y is equal to 1 now. Okay, so we'll put y is equal to this is what? 3 minus 1, 3 minus 2, this is 1 now. Okay, now we'll find y double prime now. Y double prime. You have to just differentiate this one times. Okay, this is f of xy. We have to differentiate f. So this is what? X cube. So you need to differentiate f of xy 2 times only. To find the third derivative, that means you have to differentiate f of xy 2 times only. Okay, so we'll differentiate this. This is what? 3 raised to x minus 2 y prime. Minus 2 y prime. So y double prime at x is equal to 0, y is equal to 1. Y is equal to 1. So this is what x is 0, this is 3, your y prime is 1, again this is 1, again this is 1. Okay, so y third derivative, this is what e raised to 3x minus 2y double prime, again your y double prime is also 1. So y third derivative at x is equal to 0, y is equal to 1 is again 1. So your third derivative is 1. So this is what then 1 upon 3 factorial. So this is 1 upon 6. So 1 upon 6. Oh, here this is wrong now. Here you have to write a plus sign now here. Okay, so all these solutions will be wrong now. So this will what then 5. Here this is minus twice y. This is minus twice y. So you are shifting that, this will be plus twice y. Okay, so okay, no problem for this one. So this will be the 5. So now this will what then? If this is y prime is 5, this is 10. 10 plus 3 is 13. So this will be the 13 now. Okay, so then this is 26, so this will be the 29 now. 29. So this will be what? 29 by 6. The value will be what? 29 by 6. So 29 by it is not divisible by this one. Okay, so we'll take one more problem and then we'll stop. Okay, for this we'll take the next method then. Okay, suppose dy by dx is equal to 3x plus y square. Y of 3 is equal to 4, suppose. And they want y of 1 now. They want y of 1. Okay, we will consider only the first 3 terms only. First 3 terms. So y will be what? Y naught plus x minus 3, y prime at x naught at x is equal to 3. Then x minus plus x minus 3 square upon 2, y double prime at x is equal to 3 now. At x is equal to 3. This is the this. Okay, so we'll find the solution. We'll find y prime now. Y prime at so first to write y prime 3x plus y square. So y prime at x is equal to 3, y is equal to 4 now. You have to put y is equal to 4 at x. So 9 plus 16 is 25. 9 plus 16 is 25. Okay, so y double prime is 3 plus twice y prime. Twice y prime. We have to take the care of the derivative now here. Okay. So now y double prime at x is equal to 3, y is equal to 4. So this will be what then? So this is what? 3 plus 2. Your y is what? 4. Your y prime is what? 24. So this is what then? Okay, so 100, 200, 203. This is 203. Okay, so what is there then? Y is equal to y naught. What is your y naught? Y naught is 4 plus y prime will be what? 25. So 25. So this is 25 x minus 3 plus 203 upon 2 factorial means 2 x minus 3 square. Okay, so you get a coefficient of x minus 3 square here also. If they want coefficient, if they want some value, so suppose they want the value y of 4 now. So they want y of 1 actually. So we find y of 4 now here. Okay, suppose they want y of 4 now. Because if you take y of 4, the problem will be easy now. Plus 25 plus 203 upon 2 only. Okay, so y of 4 will be easy now here. So this is what? 29. So that means what? This is 58. So this is what? 58 plus 203 upon 2. So this is what? 261. 261 upon 2. So this is 1. Then this is what? 305. So this is what? 1305 will be the required answer. Okay. So I hope that you can do any problems on the Taylor series now. Any problems on the Taylor series. Okay. Now the next method is Picard's method of successive approximation. Okay. So now here also you have to differentiate this dy by dx. dy by dx is equal to f of xy. We are finding here solution of the same differential equation. Y of x naught is equal to y naught. We are finding the solution of the same differential equation. Okay, here also. And the solution is then we have the direct, we will write the formula. This is yn is equal to y naught plus x naught to x f of x y n minus 1. Remember the formula dx where y of 0 is equal to y naught, and your starting value of y naught okay, so y naught is this. Okay, this is your y naught, no problem for this one. Okay, so you have to find y1. So what is y1 then? Y1 first I have y1, first approximate solution f of x y naught. Okay, so y naught means y1. Okay, so dx. So this is what y naught plus x naught to x f of x y naught dx. What is your y2 for second one? Y2 is what? Y naught plus y naught is fixed now everywhere. Y naught is x naught to x f of x y of 1 now here dx. Okay, so these are the this is the important thing here. Only you have to remember the formula here. With the help of this one, we will solve some simple problems. Okay, so now here what the Picard's method it is convergence, and it involves integration of f. This involves the integration of f. So here what we need the integration. So this Picard method, so it involves integration, and in Taylor series it involves the differentiation. Because terms are there in the differentiation, n time differentiable functions are there. Here what we need the integration, and it satisfies the Lipschitz condition. This condition. Okay. It converges and satisfies. That means these solutions. These are y0, y1, y2. We get a solutions. We get a sequence, and that sequence satisfies the Lipschitz condition. Okay. So this is the important thing here. Okay. Now we'll solve some problems on it. So what you have to remember? You have to remember this formula. We have to remember this as this is the y0, y1. These are the solutions. Okay, approximate solutions of this differential equation. We get a sequence of the approximate solution, and that sequence satisfies the Lipschitz condition. That means they are bounded function also here. Okay, and it involves integration now. This Picard method involves integration. So only this part is important here. Now we will see how to test the problems on the Picard's theorem now. Okay, suppose we have the differential equation dy by dx is equal to x plus y square, y of 0 is equal to 1. Okay, so we'll find first approximation. Okay, so y1, we'll find y1 now. So what is that? y0 plus integration from x0 to x. Your x0 is 0. Directly we write this is your x0 is 0. x0 is 0. 0 to x f of x y0 now. F of x y0. Okay. So what is your y0? Y0 is 1 now. Y0 is 1 plus 0 to x. Okay. F of x y0. F of x y0. So that means it is x1 dx. x1. So this is your f of xy. This is your f of xy is x minus y square. Put there y is equal to 1 now. This will what? 1 plus 0 to x y is equal to 1. So that means that this is x plus 1 dx. Now we'll integrate this. Just you have to integrate this. Okay. No, don't consider this 0 to x. Okay. Just directly integrate. Don't take the limit now here. So this is what x square upon 2 plus x now. Okay. So this is your y1 now. This is your y1. Okay. So first approximate solution. So if they want the value of this y of y of 1, directly you can find the value of y of 1 now. This is 1 by 2. So this is 2 plus 2. This is what? 5 by 2. So y of 1 will be the y of 2. Okay. So either they will ask the y of 1 or they will ask the y of 1 now here. Okay. So y of 2 also you can find. Y of 3 you can find. So for y1 now, this is what? First approximation. We'll find first approximation because second approximation will become a complicated now. What about the y2 then? Okay, we'll check for y2 now. For y2 will what? 1 plus integration from 0 to x f of x y of 1 now. Y of 1. So what we have to do here? This is very complicated now here. So this is what then? X plus y of 1 square. You have to take the square of this one now. Then this becomes very complicated now. 1 plus x square upon 2 bracket square dx now. Okay. So we'll check now. This is what? 0 to x. So this is x plus. We'll take the square. So 1 plus x square plus x to the power 4 upon 4 plus twice x square plus twice x cube upon plus twice x cube upon 2, that means x cube. And then you have to integrate this. So this is 1 plus. So now see here. There is only one constant term. So integration of constant is 8. So how many x are there? 3x are there. So this is what then? 3x square by 2. We have to take the integration. How many x squares are there? 3x squares are there. So 3x square are there. So integration of this what? 3x cube by 3 now. Because there are 3x square. Integration of x square is x cube by 3. Plus how many x cube is there? Only one x cube is there. So x to the power 4. So x to the power 5 upon 20. Okay. So this is your y of 2. This will be your y of 2. It becomes complicated now. So just concentrate on y of 1 at least. Just concentrate y of 1 now here. Okay. And if they want, so they will be asked like this also. What is f of x? What is f of x y1 now? Because what? To find y2 you need this f x y1 now. So first you have to find x y1 now separately or put there. Okay. No problem for this. You to put there now. What is that then? X y1 is what then? 1 plus x is what? X plus, no? So x y1 is what? X plus y1 square. That means what? This is 1 plus x square upon 2 square. This will be the value of this one. If you take the square of that one and just simplify this, you get fx y1 also. Okay. I hope that you understand this. Okay. So now we will take the next problem. Next problem. dy by dx 1 plus xy. 1 plus xy. Y of 0 is equal to 1. Y of 0 is equal to 1. Okay. So we have to solve. We have to find first. We have to find the first one. Y2. Okay. So we have to find f of x y1. Suppose the problem is like this. Find f of x y1. This is the problem. Then what happened then? Okay. So what is your f of xy? F of xy is 1 plus xy. Okay. So what is your f of x y naught now? So you have to find y1 first. You have to find y of 1. We will write the formula. This is what? 0. Your initial value is 0. 0 to x. F of x y of 0 means y naught. Y of 0 means y naught. Okay. So this is y naught dx. So this is what then? Y naught plus 0 to x. F of x. F of whatever this is 1 now dx. Okay. So this is what is y naught? Y naught is 1 now plus 0 to x. So what you have to put? X is equal to x and y is equal to 1 now. So this is what then? 1 plus x now. 1 plus x. So now this is 1. Just integrate this. Integration of 1 is x plus x square by 2. Plus x square by 2. Now we have to find fx y1. fxy1 is what? 1 plus x y1 now. 1 plus x y1. And what is your y1? Y1 is just multiply by x now here. So 1 plus x square plus x cube upon 2. So this is the value. Very simple now. Very simple. This is your standard formula. Just you have to find a y1, whatever it may be. You have to find a y1 and you have to find y1 of. So if they want find the value of y of 1 now by using the first approximation. This is the first approximation. So if they want y1, so 1 plus 1 half. So this is what? 5 by 2. So this is 2.5. Very simple now. Okay. Either they will ask find the value of y1, y2, something like this, or they will ask like this, f of x, y1 now. Okay. So you should be ready for this. Okay. Very simple thing. So you have to find just you try for y2 also. Just try for y2 also. Okay. For practice, do y2 also. Okay. So that means just find y1 and y2 here. Okay. For practice, y1 and y2. And if the first, this is what using the first approximation. If the question is in the question, if there is a first approximation is there, then only find a y1. Don't find a y2. Okay. Suppose you have this equation dy by dx is equal to xy, y of 0 is equal to 1. Okay. So y of 0 is equal to 1. What to do now here? So what is y? So your f of xy is just xy. Okay. So we'll find first y1 now. So this is y naught 0 to x, f of x y naught is 1. Directly we write now. Okay. So this 1. So now this is y naught is 1 plus 0 to x. So we'll write this value. So xy means you have to take the product only this. Okay. So 1 plus x square by 2. This is your y1 now. This is your y1. And if they want the value of this one, then no problem. So if they want value of x, f of x, y1, then so what is this? Just you have to take the product. xy. This is what? xy1. Because what you have to put y1 only, right? So we just multiply by this. This will what then? X cube by 2 only. Very simple. If they want this value, this. If they want y2 also, this y2 is also very easy now. This is what? Y naught plus integration 0 to x f of x y1 dx. And just you have calculated this y1. This is what? 0 to x. Just you have calculated this. Just put here. This is what? X plus x cube upon 2 dx. Just integrate this. This is 1 upon x square by 2 plus x cube upon this is x cube. So x to the power 4 upon 8. You have to take the care of this one. Okay. So this is your y2. And you can find the y2 of, suppose this is what, with the help of the second iteration, find the value of this one. With the help of the second iteration, find the value of y1. Then y1 will be what? Then 1 plus 1 upon 2 plus 1 upon 8. So this is 8. 8 plus 4 plus 1. So this is 13 by 8. This is your required answer. Okay. So I hope that you understand the Picard method. Right? This is the Picard method now. Okay. Now next method is Euler's method. Euler's method. Okay. So same thing here. What? Dy by dx is equal to f of xy. Y of x naught is equal to y naught. Okay. So Euler's method is also very simple. So you have to write this y1. Y1 is equal to what? Y naught plus h. F of x naught y naught. So then y2. The next is what? Y naught plus y1. This is y1. This is increase. This is the change now. This is f of h. F of x1 y1. y3 is equal to y2 plus h. F of x2 y2 dot yn is equal to just this is 2, then this is what? N minus 1 plus h f of n minus 1 y n minus. This is the formula. This is the formula for Euler's method. Okay. For Euler's method, there is no any comment. There is no any comments. Okay. So this is the formula. Okay. So now see here the h plays very important role. H plays very important role. What is x1? Suppose x0 is there. X0 is what? X0 is from here. What is x1 then? x1 will be what? X naught plus h. X1 will be x naught plus. What is x2? X2 will be x1 plus h. That is x naught plus twice h. X naught plus. What is x3? X3 means this. X3 means what? So x2 plus h means what? X naught plus 3h. X naught plus 3. So y of x1. Y of x1 means your y1. Y of x1 is your y1. Y of x2 means your y2. But for y2 you need previous value x1 and y1. Okay, you need the previous value. Yeah, this you have to take the care of this one. Okay, so now we will see how to solve the problems by using the Euler's method. Okay, you know that there is a Euler's modified method that is very powerful method now. That we will see later on. Okay, so we solve problems on this. So suppose we have given dy by dx minus y, y of 0 is equal to 1. Find y of 0.02. Take h is equal to 0.1 suppose. 0.01. Oh, if you take the 0.1, becomes 0.01. Okay, so what is this? Your f of xy is what? F of xy is minus y. Your x naught is 0. Your y naught is 1. Okay, your h is 0.01. H is what? 0.01. So your x1 is what? X naught plus h. So x naught plus h is what? 0.1. So x2 will be what? 0.02. And you want this one. That means what? You want to find y2 now. That is what? You want to find y2. So we'll find y1. Y1 is equal to what? Y naught plus h. Y1 is equal to. Just you have to find y2. Note that. So for this, you have to find y of this. That means you have to find y2 only. Okay. So y1 is equal to y naught plus h f of x naught y naught. What is your y naught? Y naught is 1 plus h is what? 0.01. Take care. This f of x naught y naught. So that means minus y naught. What is y naught? Y naught is 1. Minus 1. So this is 1 minus 0.01. 1 minus 0.01. So this is what? 0.99. You have to take the care of the subtraction also. This is minus 0.99. This is your y1. Okay. So what is your y2 then? y1 plus h f of x1 y1. Okay. So what is your y1? Y1 is 0.99 plus h is 0.01. Okay. Into minus x1 y1. So f of x1 y1 is minus y1. So your y1 is minus 99. So this is what? 0.99 minus. So product is 99. So this is what? Minus 0.99. Right? And this will be what? 0 now. This will be 0. Oh, 0.99. This is 0.99. Oh, people. This is minus 0.99. Oh, we have to take the care now. This is. Take care. Okay. So this is what is 0.99 minus 0.99 minus how to take the product? This is what? 0.00499. Right? Product is 99. You have to take 4 decimal places. Okay. Now we have to do this. 0.99, 0.0099. So this is what? 1. This is 0. This is 8. This is 8. So this is what? 0.8801. This will be the required answer. Okay. So check the answer for this one. Okay. Now we'll take the next example. Very easily you can find the value. So dy by dx, x plus y. Any function you can take here. So y of 0 is equal to 0. H is equal to 0.2. You have to take h equal. Find y of 0.4 now. Y of 0.4. Okay. So now this is your f of x y. We'll find y1 directly. So we'll write. You have to write a formula. This is what f of x naught y naught. Okay. We'll do some fastly. This is 0 plus h into 0 plus 0 is 0 now. Whatever the h may be. So your y1 is 0. Your y1 is 0. Okay. So very nice. If y1 is 0 because y of 0 is 0 is 0. Okay. So that means what here? Okay. So here what? Your x naught is 0. Your x1 is what? Your h is 0.2. So 0.2 now this. Okay. Your x2 is what? 0.4 now. That means you have to find y2 now. You have to find y2 only. So y2 is equal to y1 plus h f of x1 y1. Okay. So your y1 is 0 now. Your y1 is 0. Your h is what? Your h is 0.2. 0.2. Now x1 plus y1. Your x1 is what? x1 is 0.2. Your y1 is 0. So 0.2. So this is 0.04. 0.04. Your y2 is 0.04. This is the required answer. It will be the required answer. 0.04 is your y2. Okay. So very easily you can obtain the values. Okay. We'll take one more example. Dy by x is equal to 2 plus root xy. Y of 1 is equal to 1. Y of 1 is equal to 1. So find y of 1.5. Y of 1.5. Okay. So take h is equal to 0.5. Okay. By using the Euler's method. Okay. Okay. So this is f of xy. So that means what here? Your x naught is 1. Okay. So your x1 is 1.5 and you want 1.5. That means only I have to find y1. So y1 is equal to y naught plus h f of x naught y naught. So what is your y naught? Your y naught is 1. Your h is what? Your h is 0.5 and this is what? 2 plus root of. You have to take the product of this one, x naught y naught. So what is your x naught y naught is 1. So this is 1. Okay. So this is 1 plus 0.5. So this is 3. So this is what then? 1 plus point. This is 1.5. Note that. So this is 2.5. This is 2.5. Okay. So in this way you can find any problems. Any problem you can find this. So I hope that you understand this one. Now the next method is Euler's modified method. So this is superior than Euler's method. This is superior than Euler's method. So only you have to remember the formula for this one. y1 of n plus 1 is equal to y0 plus h by 2 f of x naught y naught plus f of x1 y1 of n now. So this is iterative method. Note that this is the iterative method. Okay. So we have to do the iteration up to the you have to do the iteration up to the some correct value of this one. Okay. So now this is obtained by trapezoidal rule. That means what? To find the solution of this one, we need to apply the trapezoidal rule. That means we get the solution with the help of the trapezoidal solution. So this is the initial value problem modified up to the desired accuracy. This is the very important. Desired accuracy before proceeding to the next iteration. That means what? You to find y1, to find y2, you have to find a desired y1. You have to do the number of iteration on y1. Okay, once we get the desired value of y1, then we can find a y2. So if you don't get the desired value of y1, you cannot find a y2. Okay, so this is the important here. So we get a desired accuracy. Up to the desired accuracy, to find the next approximation, before that we have to find a desired accuracy for the previous root. Okay, so this is the important here. Here the value of y1 of 0 is what? Then y1 of 0, you have to start from here, plus h f of, initially you have to start from, this is also depend on the initial value. Okay, so your initial value y1 of 0 is this, then you have to find y1 of 1, right, y1 of 2, y1 of 3, y1 of this, up to the desired accuracy, you get y1 then. Okay, so this is a very complicated this is very complicated, but it is a very accurate method than the Euler's method. Okay, so only remember this as a formula only for this one. Okay, so problems are very complicated here, so we will not do any problem on it now. Okay, so problems are solved, just check, at least do the one iteration or two iteration for this one. So just like as a Euler's method now. So okay, solve y1, at least find y1 of 1 now. Okay, so do the solve problem with the help of y1 of 1 only. Okay, now next method, that is the last method, is Runge-Kutta method. So for this is the second order Runge-Kutta method and fourth order Runge-Kutta method. Okay, so this is what. Okay, so for Runge-Kutta method, second order and fourth order only. Okay, second order and fourth order only. Okay, so we will see only the formula. This is what y1 is equal to y0 plus 1/2 k1 plus k2. Only this is very simple formula for this one. There is no derivative, there is no anything. So value of k, f f0 is same as what? F of x0 y0, and value of k1 is h f0. That means what? H f of x0 y0. Don't remember this f0 is just remember this, k1 is equal to h f of x0 y0, and your k2 is equal to h f of x0 plus h y0 plus k1 now. Okay, so it involves only the two constants k1 and k2. Okay, so this is the second order Runge-Kutta formula. Second order Runge-Kutta formula. Second order. Only remember this. Okay, remember this and remember the values of k1 and k2. These are the formulas, very important now here. These are the formulas. With the help of these two, the problem will be asked. Find the value of k1 plus k2, or check whether k1 is less than k2 or k2 is less than k1, something like this. Okay, so find the value of k1, value of k2, or find the y1 of 1, something like this. Okay, and for this one, this is very important, y1 plus 1 upon 6, k1 plus twice k2, twice k3, k4. Okay, so now k1 is equal to, k1 is same now here, k1 is same as this. Okay, h f of x0 y0, but k2 is different now. This k2 is same as h f of x0 plus h by 2 comma y0 plus k1 by 2. Okay, remember this formula. This is h f of x0 plus h by 2. This is same, y0 plus, now this is k2 by 2 now. This is what? K2 by 2. Okay, now k4, h f of x0 plus h x naught plus y naught plus k3. Oh, y naught plus k3. Y naught plus k3. Okay. So this is the formula. This is the formula, and these are the k1, k2, k3. So in the fourth order, this is called fourth order Runge-Kutta formula. In fourth order Runge-Kutta formula, there are four constants. There are four constants, and these are the values of k1, k2. Okay, so you should remember the formula for k1, k2, k3, k4. So note that k2 is dependent on k1, k3 is dependent on k2. That means k3 is also dependent on k1. K4 is dependent on k3. K4 is dependent on k3 means k4 is dependent on k2 and k1 also. Okay, so they are the difference. So now k2 is not dependent on k3 now. K2 is dependent on k1. But k3 is dependent on k2 means k2 and k3 is dependent on k2. So k3 is content, k4 contains k3, and k3 is dependent on k2, and k2 is dependent on k1. That means what, k4 is dependent on k1, k2, k3. Without finding k1, k2, k3, you cannot find the value of k4. Okay, but without finding k2, k3, k4, you can find the value of k1 only. Okay, so this is the important thing here. And here what, it is application of Euler's. So how we get this formula? With the help of the Euler's method. Euler's method we get this. Okay, so that means what, to derive the Runge-Kutta second order formula, we have applied the Euler's method. Euler's method, not modified. So Euler's method only we have applied. Okay, so we'll take a problem. Okay, so dy by dx is equal to x plus y. Y of 0 is equal to 1. Find y of 0.1, h is equal to 0.1 by using Runge-Kutta formula, second order formula. By Runge-Kutta second order formula. Just we write the Runge-Kutta second order formula, that is y1. You have to find c. H is equal to this. This is 0.1. Okay, so that means we have to find only the y1. Okay. So h is 0.1, y is also 0.1. That means we have to find y1. Okay, y1. So that is what, y0 plus 1/2 k1 plus k2. Okay, so we'll find first k1. K1 is what, h f of x naught y naught. What is h? Is 0.1. Okay, f of x naught y naught means x naught plus y naught. Your x naught is 0, so this is 1. So this is 0.1. So your k1 is 0.1. We'll find k2. K2 is what? So formula for k2. So you need the formula for k2 is equal to h f of x naught plus h y naught plus k1. Y naught plus k1. Okay. So h is what? H is 0.1. X naught. Okay. So first we'll write x naught. First simplify this, and then we'll take the sum of this one. Okay, so y naught plus h. So your y naught is what? 0, and your h is 0.1. So this is 0.1. Y naught plus k1. Your y naught is 1. Your y naught is 1, and your k1 is 0.1. So 1 plus 0.1 is 1.1. 1.1. Okay. So then this is what? 0.1 into. You have to take the sum of this one. That is 1.2. That is what? 1.2. And the product is what? You can take the product is what? Again 0.12. Product is 0.12. Okay. 1 into 12 is 12, and this 1 decimal, 1 to 2 decimal you have to this. Okay. So we'll find y1 now. Y1 is equal to, what is your y naught? Is 1 half k1 plus k2. K1 plus 0.22. So this is what? 1 plus 0.11. So 1.11. This will be your answer. Okay. So I hope that you understand this one. So what here? K1 is what? K1 is 0.1. What is your K2? Is 0.12. So K1 is what? Less than K2 now here. Less than. If you want K1 plus K2, so you have already calculated K1, you have already calculated K2. Then K1, K2 is what? Just you have to take the addition of this one. Is 0.22. Is your, check whether which one is the correct. Okay. So if only the problem is asked for K1 and K2, just find K1 and K2 only, don't find this Y1. Okay. So if they ask the value of this relation, whether K1 is greater than K2 or K1 is less than K2, just find the value of K1 and K2 only and just compare them. Okay. If they want the value of K1 plus K2, just find K1 and K2, just find K1 plus K2 and just compare your answer. Okay. So this function plays very important role here only. Okay. So all the theorems, all the problems are there. Okay. So take the care of the function. Okay. So try to solve all the problems. Okay. So you have to take the care of this one now here. This is 0.1 and this is h1. Okay. See, if they ask this y of 0.2, then the problem is what? And they will not ask like this because this is very complicated actually. Okay. So remember this. I hope that you can do the any problem on the Runge-Kutta method like this. Okay. So if they ask this what y pi of 2, they will give the point 2 now. They will give the h value is 0.2. Then you have to find only the y1. Okay. Both are the same. Then you have to find the value of y1 only. But if both are the not same, this is 0.4. Then you have to find the y2 then. Right. And to find y2 it is complicated now. To find y2 it will be the complicated now. Okay. So that means what here your k1 and k2 will be changed now. So what is your k1? K1 is what here? H f of x0 y0. Then in the this verb to find y2, your k will be what? H f of x1 y1. F of x1 y1. This is what then? H x1 plus h y1 y0 plus k1 now. Your new k y1. This is y1 then. Now that becomes a very complicated now. So what here? So if this is then this is what? The problem will be complicated. So if both are the same now here, both are the same, then do this. That means we have to find only the y1. Just simple, you have to find k1 and k2 only. So I hope that we have revised all the 4 chapters of this numerical methods and its application. So try to solve the number of problems for the practice one. Change this value of this one also. Instead of y of 0 is equal to 1, take y1 of 1 is y2, y3, y4 here, so that the problem becomes complicated and easily you can solve the problems. Any problem, this if you take the y3 is equal to 1, no problem for this. Your x0 will be what? Only the 3 here. Okay, so you can do this one. Okay, so this is initial for value problem for x is equal to 0. So instead of that you take this is what y2 is equal to 1. So your x0 is equal to 2. Okay, so do this problem for k1 and k2. Find k1 and k2. So only k1 and k2 plays important role in the second order Runge-Kutta formula. Okay, so we will stop here. Thank you very much.